This video is going to give you a little bit of a review about mechanical energy and work, how energy changes, and I'm going to apply it to thermodynamics and the gas. To begin with, when the mechanical energy of a body changes, physicists don't say that the energy changed. Instead, we use the phrase that work was done. So work is how we describe the change in energy. It's also measured in joules, just like energy, because it's a change in energy. So to find the magnitude of the amount of the change, what we do is we calculate the magnitude of the work. And so the work is equal to force parallel times d. That is whatever component of the force that's parallel to the distance. You take those two numbers, multiply them together, and you get the work. Essentially, it's what's called a dot product. Alright, so here's how I can find the magnitude of the work. But how do I find the sign? Because I can add energy and I can remove energy. Here's the way it's done. I've got a person pushing a car. As they push the car will go faster and faster and faster. So it's going to gain kinetic energy. So if I look at this in terms of force and distance, these two go in the same direction. So energy will be gained by the car. And that gain comes because energy is added by the person pushing. So when the force and displacement are in the same direction, physicists like to say that work is done by the source of the force. So work is done by the person's force. Mathematically, we make this a positive work in our formulas. How about a negative work? Well, here's a little different situation. The car is rolling to the right and the person's trying to slow it down by pushing against the car as it rolls to the right. So the car rolls to the right, the force pushes to the left. So here, energy is removed from the car as it slows down. So that's because the displacement and the force are in opposite directions. So when displacement and force go the same direction, energy is added to the body. When they're going opposite directions, energy is removed. So what we like to say is when the displacement and force go in opposite directions, work is done on the source of the force. So work is done on the person in this case, because the person's force is going left and the car or going to the right. Therefore, the person's also going to the right. So mathematically, this work is negative. So how does this relate to the gases? Well, here's our example system in thermodynamics. We have a container that has a piston in the middle that can slide up and down. I've got the force of the gas pushing up, and I've got the force of the surroundings, or the environment, pushing down on the gas. Over time, let's just let the gas expand on its own. If we let it expand on its own, it'll push upwards. So it moves through some kind of distance d. So the gas's force goes up, and the distance the little piston went is also up. So what we say is the displacement, since they go in the same direction, the work is done by the gas. That preposition by means a positive amount of work mathematically. But look at the surroundings. The force of the surroundings goes down and the displacement went up. The distance it moved went up. So therefore, since they go in opposite directions, we say work is done on the surroundings. So it's negative mathematically. The sign of the work for the gas and the sign of the work for the surroundings are opposites. That's important, because in thermodynamics, we care what the signs are and which ones are which. Now let's look at a little different situation. Suppose, this time, the force is greater, and it's allowed to expand downwards. So now it's moved through some kind of distance, d, or displacement, and the force and the displacement that it moves, they're in the same direction. So this time, we can say the gas's force and the displacement are in opposite directions. Force goes up, displacement goes down. The work done on the gas is negative work. Likewise, the force of the surroundings is going in the same direction as the displacement. So now work is done by the surroundings, and that's positive work. So I've got the opposite of what I just said previously, because I'm looking at the gas expanding and the gas contracting. And by saying gas, I mean the gas in the bottom of the cylinder, because that's our system. So now I've got the magnitude of the work, and I can figure out if it's plus or minus. Now let's look at this a little bit more closely. So what I know is this. I know that work is equal to force times distance, and I just showed two examples. And if I look at this a little bit closer, I can see that I can do something tricky mathematically. I can do something to the right side without changing the value of it. What I can do is I can take the force and divide that by area, and then take the displacement and multiply that by area. So mathematically, the number for the area would cancel out, because it's in the numerator and the same side of the equation. It's also in the denominator, so they would cancel out. But when I look at it a little bit closer, I can see that force over area is just pressure. So now I'm talking about pressure. So pressure times distance times area. But distance and area are perpendicular to each other, because I've colored the area yellow, and you can see it's perpendicular to the distance that it moved. So when the distance and the area are perpendicular like this, what I'm tracing out is the area of a volume. And because it changed, it went from some volume to another volume, It's actually not just a volume, but it's a change in volume. So the work is equal to the pressure times the change in volume. So in order to calculate the mechanical work associated with our system, which is the gas, you have to have a pressure and you have to have a change in volume. Changing pressure does not give you what you want. You have to have pressure and a change in volume in order to get the work. And this work is going to be work done by the gas when we're looking at this, because that's going to be our viewpoint of how things operate. So the work is pressure times change in volume, and we'll call that by the gas. And we can look at it as also being on the gas will help us figure out if it's positive or negative. We'll look at some examples and you'll see what I mean.